At this point, I'm going to hand it over to Beth, who has already been participating. She's an OpenDev veteran to talk about what Verizon's been up to, and then we'll do Q&A after that. Thanks, Beth.
Okay, let me share my screen. Let's see, screen 2 is the correct one. We just set it up. This should do. Okay. Of course, now I can't see my own screen, so you'll have to tell me if it's correct. But I think
looks good.
Okay. Done a few of these. So I'm going to be talking about some of the really interesting things that we've been that's been happening with our OpenStack implementation. We have a number of them actually, but this particular one, which is called the Verizon Cloud Platform, is used by our networking team for, among other things, the 5G deployment. But in this particular case, it's also used by our commercial customers. We provide services to our commercial customers to support networking applications. One of the reasons I asked the question earlier to the Blizzard folks was because in our case, these are applications that are not owned by us. They're from our partners. So it's a very different relationship with how it works with the underlying infrastructure. So I'm going to talk a little bit about, sort of what the issue is, which is we have vendor applications that have very erratic and behavior on our cloud. What we did about it, and then I'm going to give a little user story for one of our customers. So here's the issue. So we have this lovely OpenStack infrastructure. It's distributed in 32 nodes around the world. It's all great. I'm embarrassed to say it's running on Newton, but whatever. And what we were seeing is the applications, again, which are not typically written by Verizon, but they're typically partners like firewall companies and SD-WAN companies, networking companies, those types of applications. And what we were seeing is that how they were configured had a significant effect on how they behaved in the environment. So, if for example, one customer had turned on the encryption, all of a sudden the throughput literally halved. So we also found it was difficult to determine who was at fault, right? So particularly when we have service chains like firewall, routing, WAN optimization, all this traffic is going through all of these systems, and it's like, okay, whose problem is it? We also found, unsurprisingly, that the vendor performance reports, which they did admit were done in ideal conditions in their labs, clearly did not work the same way in real life. And another thing that's actually kind of surprised me, some of the vendors were really good at optimizing to OpenStack, and others just literally did a lift and shift and did nothing to take advantage of the optimizations that are built into the OpenStack environment. So what did we do about it? What we did, and unfortunately, some of our customers were affected. So that's embarrassing, when a customer turns on, who knew that a customer would want to send voice traffic through their firewall? Wasn't something we thought about, but now we ask them because one of our customers did, and immediately the performance went to hell. So what we've done is we have built a full production engineering lab with full testing capabilities, and we use it for both tier 4 and tier 3 problems, troubleshooting, as well as it's used for by our development team. So that gives a really nice feedback loop. So a lot of the problems that are uncovered by our tier 4 team can be, fold back into what we, development efforts to improve the products, as well as, informing our sales teams. So, for example, the example of the customer that ran voice traffic through their firewall, we now ask that question of all our customers. Well, what type of traffic are you actually planning to send through this firewall? Because, if they tell us that they're going to be doing something that is going to put stress on the firewall, we can configure it that way. But now we know, and because of the lab, exactly all the different nuances. Another thing that's important is we work closely with the vendors. So it's not just us, but it's also collaboratively with the vendors. So when we uncovered the fact that some of the vendors had not been optimizing to OpenStack, we were able to feed that back to them. And in one case, one of them had to substantially rewrite their application that took several months. But in most times it's not that extreme, but one vendor was pretty much caught with egg on their face. So moving on, just kind of take some lessons. This is a typical service chain that we run. This happens to be in the hosted environment, but we also have the other thing about our OpenStack implementation is we have the large nodes, but it's also on edge devices as well. So we actually test that in our lab also. And again, the effect of the network can have some significant effects on the performance in both environments. So our lab is able to look at both of those. So lessons learned. We verify any vendor comes in and says, this is how their application performs. We test it. We often find that, just encryption, for example, just changes the performance. There's a couple other things that have significant outsized impacts. We also test all the integrated service chains. So we actually have about 35 of them now. And one of the reasons why we don't have as many as we'd like, because the actual number of combinations is a couple hundred, is because we have found that we do actually have to do full performance testing on every single service chain. We have not been able to, we obviously have automated the testing, but it still takes a couple months for each service chain to go through, not just the testing of the service chain in our automated test harness, but also how it works in operations, setting off alarms, making sure everything all works. So that's a value to our customers, of course. And as I said, we do ask our customers to prevent unpleasant surprises. So I'm going to talk, and unfortunately, I don't have a clock. So Jonathan, you'll have to, or sorry, Mark, you'll have to kind of give me a little heads up.
Yeah, you're right on time. You're doing great.
Good. Okay. So I want to talk. This is a case study. This is a large financial institution. And they started seeing performance issues show up. It wasn't immediate because they weren't stressing the system, but in May of 2019, they started seeing weird behaviors. They started seeing low bandwidth and micro freezing of the application. And it affected it affected their security application, but it turns out that this particular issue affected all security applications. So we just hadn't seen it with other customers because this customer was the first one to stress things out. And in fact, what stressed it out is they started running their voice traffic through their firewall. They just had a standard policy that all traffic from within the company had to go through a firewall. End of discussion. So what we did about it is we made some changes to how the VMs were stood up within the environment. What's interesting is we didn't actually have to make any changes to the host environment, which means that we had actually configured the OpenStack correctly. We just were hoping that we could take advantage of not having to pin the CPUs, and pin the VMs. We also, the SRIOV, we turned that on as well. Again, we had it, but it wasn't turned on by the vendor hadn't turned it on. And in one case, the vendor had to re-architect their VM to support it. So we are now standardly pinning all these VMs and making. We're looking at standardizing an SRIOV deployment for all future applications that we bring in. And again, this will all be, this is all of the conversations we have with customers as they, as with partners as they onboard in our systems. So this is just an overview of the throughput issue. So kind of bits and bytes here. It affected all the vendors except for one firewall vendor who had actually done it correctly. And all the SD-WAN vendors had also not done it correctly. It was particularly true of latency sensitive deployments, such as voice over IP. And it only affected larger transports. So under 100 meg or 100 meg and under was fine, and over a gig, it fell over. And 2 gig, I think we finally tuned it to some of them can support 2 gig, but most of them still can't. So we've turned off over subscription and improved the network interface. So here's just some sample of the guidance. So this came out of our testing. We have we give these to the sales teams and the solutions architects so that they can guide the customers. And you'll notice I highlighted the one where it fell over. Now, in this case, it was because we turned on encryption. So we now, warn customers, you will never get full throughput if you turn on encryption. And here's a SD-WAN applications or similar types things. Some cases it makes it through, some cases it doesn't. We use 3 different testing suites. And again, these are all industry standard type traffic testing patterns. And we take the worst case. We want to be conservative with our customers and to make sure that they understand the issues. And just in summary, customers obviously are looking to Verizon to, for us to meet our SLAs. But, unsurprisingly, customers do weird things with their applications. And we make sure to work with the vendors. That's something we can bring to the table because often our customers cannot have that tough conversation with, let's say a routing vendor and a firewall vendor and, basically get together with them and say, okay, guys, let's solve this problem. So with that, I'm going to open it up to questions.
Great. That was amazing. Appreciate all the detailed examples. So one of the questions, Beth, that came in from chat or maybe on the Etherpad was, is it possible to reproduce all the customer issues in the lab environment?
It is, because the lab is connected to our production network. So in fact, it is the production network. In the case of that particular customer that we originally had the problem with the voice over IP traffic, they actually gave us a set of traffic. So they collected a couple hours worth of traffic. So we could literally duplicate their traffic. But we've also had customers where we fork traffic. So, we'll take literally their production traffic and run it through the lab.
Good. Well, I think this might be kind of another spin on the same question, which was, do you test the applications on behalf of the users, which it sounds like you do, or do you offer the lab for them to test it, I guess?
We do not. No, this particular lab is not one that the customers use. This is one we test for them. We do have other labs that customers can bring in their applications, but these are managed applications. So typically customer would not have access to it directly.
Okay, cool. Next question was, do you make changes for the pinned vCPU at the hypervisor level?
That's a good question. I think we do, actually.
Good. So I don't know if we have any other questions, because I think that we may have gotten to all of them. I think, one of the things I know you're involved in with this event is you're moderating a session later this week. Can you tell us what session you're moderating and what you're expecting to cover in that session?
I'm moderating with Chris Price. I am moderating.
HHA Networking.
Oh, right. Sorry. I looked at it this morning. Yes, so I'm going to be talking about, so that's a great session. As you know, Verizon's a networking company, and networking has its own challenges, particularly around OpenStack, and actually even more so containers. So we're going to be talking about what does high availability networking mean in the context of software-defined networking. So pretty exciting. That's something that we've been working on pretty heavily within Verizon, not only for our customers, but also, of course, internally for us as well. So.
Good. And I know that we're already seeing with the earlier users, folks that are participating have added more questions, and the users have been answering them in the Etherpad. So we're going to keep talking about the importance of Etherpads, but so much of the collaboration happens in there. So if you're having questions for Beth or for the other users, keep putting them in the Etherpad, and I'll keep signing them up for answering your questions. And it looks like we did have one more question that was actually for the Blizzard team, since we have a couple of minutes before our break. If Eric is still available, it looks like he's putting down his headsets. This is a good sign. So the question was, World of Warcraft, WoW, I think is the abbreviation, is generally has huge bursts in scale, like the classic launch, the World of Warcraft classic launch. What is the infra game plan usually like pre-launch? That was a question from Mohammed.
Colin, you want to take this one?
Yeah. Can you hear me okay? I'm
Yes.
muted here. Perfect. I just wanted to see the question. Whereabouts are we here? Is it in the...
I think it might have been in the chat earlier. So
in the chat.
Scroll back. Just preparation for a pre-game launch.
Yeah, perfect. Yeah. So, like I mentioned, we're very much multi-cloud, and for what that gives us is the capability to kind of hedge, right? You can kind of hedge for success, hedge for less than success. But we would run quite a part of our game instance workload in public cloud, and that gives us that kind of reach globally, but it also gives us that burst capacity. Typically, working with a game team, we work in scaling units, so we basically translate concurrently connected users into a pod of capacity, and we deploy based on I guess marketing data. It's all the usual kind of secret sauce that happens, but effectively we deploy more than we expect to use, and like whether it's through auto scaling or direct SRE involvement, we scale that based on a kind of day one launch day performance and behavior. Often, and a lot of games that operate today have different technologies to help protect the player experience. So, for example, if too many players connect and you don't have enough capacity, and you see that all the time in the industry, you've technologies like logging queue, where users has to come through WAT and through the kind of, I guess, the gateway services for that particular platform that you're running with. The users get queued, you get a kind of comfort message, you know where you are, and very much that was almost a traditional classic experience, and became a bit more lore last year as people reconnected with the whole queuing experience, even within the game.
Okay, thank you. That's great. And I think, I'm guessing Mohammed must be a big gamer because he has got a ton of questions for you. I know he's also a huge open infrastructure guy, but man of many talents. So Mohammed had a follow-up question. If you can disclose what was the biggest launch from an infrastructure side?
Biggest launch from an infrastructure side. Well, I won't get into too much detail, but Overwatch in 2016. Really because it was a departure from the traditional games Blizzard had operated, moving into the world of first-person shooters. You're moving into like running the physics sims on the actual game instances on servers that need to be close to players. So suddenly you transition from kind of more, I guess, less latency sensitive to extremely latency sensitive, and 120 frame per second competitive gaming within Overwatch requires quite a lot of infrastructure, quite a lot of network I/O, and proximity to the player base. And as part of our strategy back then that was a big push into multi-cloud, hybrid cloud with consuming public providers to get us reach and proximity to players in geographies that we didn't own and operate infrastructure at the time. So yeah, it would have been Overwatch.
Wonderful. I know Overwatch is insanely popular, so that's awesome. So I guess one last question maybe for the Blizzard team is about your scale. I know we're talking about large scale operators. You mentioned some great numbers in your presentation, but maybe just to recap, how big is this infrastructure you're operating on?
Yeah, across all of our regions and including production development and some of our different kind of non-production environments is about 12,000 computes
Wow.
distributed globally, and that's across the Americas, Europe, China, Korea, Taiwan, and Australia also.
That's amazing. Well, thank you all. I want to thank the Blizzard team, the OpenInfra Labs team, and Verizon, Beth, for sharing these use cases and for all the work you're going to do in the Etherpad next when we move on, because I know people have tons of questions and want to connect with you to work moving forward. And we have so many great stories today and many great sessions ahead. So I just invite everybody to take a quick break. We're going to take about a 10-minute break, and then we're going to dive into our first more roundtable style with Belmiro, our moderator. So we'll be listening to Belmiro. He'll be our guide through the wonderful journey of upgrades that, maybe he can help Beth get off of Newton. I don't know. So, sorry, Beth, that was a cheap shot. But anyway.
We are thinking about it, but we are telco, so we take things slowly.
Sure. No hurry. But when you want the person to talk to is definitely Belmiro and the team at CERN. So I think at this point, we're going to pop up the break slide, and you can enjoy a little bit of music if you're staying on, but we're going to be coming back at 7:30 Pacific, about 10 minutes from now. The time's here on the slide, 14:30 UTC. So in about 10 minutes, we'll be back with upgrades with Belmiro from CERN. Thank you all so much for joining. We'll be back soon.